Hi, welcome back to Science 1206, the Weather Dynamics Unit. I'm Miss Ledwell, and in this video, we'll talk about Earth's energy budget. Let's begin. Earth operates like an accountant with solar energy, ensuring a balance between what it absorbs from the sun and what it emits back into space. This balance is crucial for maintaining Earth's average temperature, which makes life on Earth possible. Earth's energy budget includes all forms of energy entering and leaving Earth, and each of Earth's spheres has an important role in this process. The balance between the reflection and absorption of solar radiation maintains the energy budget of Earth. Let's take a look at this diagram showing Earth's energy budget. 50% of radiation is absorbed by land and water. Clouds and particles in the atmosphere reflect 25% of the radiation. 5% of radiation is reflected by land and sea surfaces, and 20% of radiation is absorbed by particles in the atmosphere. Notice that if we add up all these percentages, they add up to 100%. So this is the total energy budget. So once more, a summary of Earth's energy budget is 50% of radiation is absorbed by land and water. Clouds and particles in the atmosphere reflect 25% of the radiation. 20% of radiation is absorbed by particles in the atmosphere. And 5% of radiation is reflected by land and sea surfaces. And again, notice that this adds up to 100%. Different colors have different wavelengths. As a result, some colors absorb more heat energy than others. Light surfaces reflect energy, while dark surfaces absorb the most energy. Let's take a look at the colors of rainbow and which colors absorb the most energy. The least amount of energy absorbed would be by white, followed by red, orange, yellow, green, blue, indigo, violet, and the most energy absorbed is by black. Now let's look at the term albedo. The amount of energy a surface reflects is known as albedo. A high albedo indicates that a significant amount of solar energy is reflected rather than absorbed, leading to a cooler surface temperature. For instance, a field blanketed in snow demonstrates a high albedo by reflecting approximately 70 to 80% of the incoming energy. Generally, lighter colored surfaces, such as snow, are efficient at reflecting energy and therefore have a high albedo. A low albedo indicates a surface that absorbs more solar energy than it reflects. The absorption of solar energy leads to an increase in the surface's temperature. For example, during summer, a grassy field might only reflect about 20% of the sunlight that hits it, thereby having a lower albedo compared to a snow-covered field. Having a lower albedo causes the field to be warmer because darker surfaces generally absorb a greater amount of energy than lighter ones. Let's take a look at this graph of albedo values of different surfaces. First, notice fresh snow. On this scale, fresh snow has an albedo value of 0.80. Compared to the other substances in the graph, snow has a very high albedo. Sea ice also has a relatively high albedo. The value here is 0.60, and if we look at the height of the bar, we can see that it's the highest next to fresh snow. Notice that sea ice and fresh snow are lighter colored substances. Lighter colored substances have higher albedos. Next, let's look at asphalt, what the pavement on the roads is made up of. That has a very low albedo. The value here is 0.05, and we notice on the graph it's the smallest bar. Dark colored surfaces have a low albedo and they absorb a lot of energy. Let's also take a look at dark soil, We notice the value is 0.15. Dark soil also has a low albedo. That means it absorbs a lot of energy. Now it's time to review, but before you complete the learning activities for this lesson, watch the video What is Albedo that follows this instructional video in Brightspace.